Okay, robot fans, now that you got your shiny new robot, and it's time to make it drive. We're going to do that by writing a program using Visual Studio Code. That's our integrated development environment of choice that we'll be using in the class this term. And so let's get going. After you got Visual Studio Code installed and you have Platform IO installed, what you need to do now is create a new window. And you can do that by using the File New Window menu, or you can do, on my Mac, Shift Command N for New Window. And here it is. It's popped up on the screen. We'll get rid of the welcome page. And now what we need to do is create a new project. Platform IO, which is the extension that's installed into VS Code, lets you write Arduino programs. And the Romi is really an Arduino. And so the way to do that is by clicking on the alien head. That's the icon for Platform IO. Go to Platform IO Home and click Open. Yours may just open automatically or be open by default, but if not, then you should do this. And now we're going to create a new project, and we'll give it a name like My First Romi Project, and you can call it whatever you want. And then you select a board type, and this is a Plolu 32U4 board. That's the type of Arduino module that it is. And so I can type 32U4 and it will filter this list of possible boards down to the ones that contain 32U4. And I'll click the Plolu A* 32U4 board. And that's it. And then this is the location where the project will go. By default, it's going to go inside of your documents folder, and inside of there's a Platform IO folder, and inside of there's a projects folder, and then it will use the name of the project. So inside there'd be a My First Romi Project folder that will contain all the files. And so you say finish, and that's it. So now the project is getting created, and you can see Visual Studio is doing its stuff. And once again, we have a welcome screen, which we still don't need. So I'm just going to close that. And here's our Platform IO home directory. So what we've got to do now is tell Platform IO about the libraries that we want to use to write our Romi program. And to do that, and other Platform IO parameters for building your program, that we go to the platformio.ini file, and we put something in here. And what we do is the line that we want to use looks like this. And this gets the library, the WPI-32U4- library from GitHub, from the WPI Robotics Engineering group that's on GitHub. And that makes it available for your project. And then if you look at source, SRC, this is where the source files or the C program files are that you're going to use. And it left us with a main.cpp file. So installed that there, ready to go. And this is where you put your code. And so the first thing that's in here is an include file, which brings in the definitions from that 32U4 library and makes them available to the program. And actually, by default, for an Arduino program, it would be arduino.h, the header file. But for the Romi and for the 32U4, we want to use Romi 32U4.h. Okay, so that's the file that will have all the headers and stuff for all the functions that we want to use. And then this is the setup function, which is called one time when the program starts up. And inside of here, we want to start up the serial monitor. So we say serial.begin 9600. Okay, the next thing is that we want to create a motor. So it's a Romi 32U4 motors object, and we'll just call it motors. And this will be both the left and right drive motor. And then down here, we put code that we want to have run repeatedly as the program is going. And what we want to do is just write a program that runs the motors for 1 second, then turns them off for 1 second, then runs them for 1 second, then turns them off for 1 second. So I'm going to put the code for that here. Before I do that, let me show you how to build the program. If you come down here to the little check mark, and you wait a second, you see the tooltip pop up and it says Platform IO Build. If you click this, this is actually going to build the project. And the first time it builds it, it's going to take a little while because it's got to go get the framework from GitHub. But after that, it will go a little bit faster for subsequent times. And so now that it's built, then some of this stuff will kick in VS Code to be able to help us write the program. And in particular, it will know about all the functions that are available, or all the methods that are available for these classes that we're using. So if I type motors dot, now it shows us a list of all the things you can do with the motors. And what we want to do is just set the efforts for the two left and right motors. So I can type set, and now it narrows down the choices, and I can type EFF or T. EFF. I'll get this. EFF ORTS F set efforts, and the range of values, as you can see here, is a number from -300 to 300 for full backwards to full forwards for the speed of the motor, for the right motor and for the left motor. And so I'm just going to set them both to about, I don't know, 60 and 60. So that's nowhere near full speed, so the robot doesn't drive away or do anything bad. But it's fast enough so you can see it going. And then I'm just going to delay for 1 second. So I can say delay 1,000 for 1,000 milliseconds. Then I'm going to stop the motors. So set efforts 0 and 0, right? Because 60 was a speed between 0 and 300 that made them go about 1/5 speed. Now we're stopping them by setting the speed to 0. Negative speeds go the other way. And then we'll delay again. Now notice as I'm typing, it's giving me choices. When I type the open parentheses, it pops up a thing that says, oh, the delay is in milliseconds. It's an unsigned long millisecond number. So that's 1,000 milliseconds, which is 1 second. And that's really the whole program to do this. So what we'll do is give it a try. So I'm going to come over to the Romi and turn it on by pressing the button. Oh, and it's actually running from the last time that I downloaded the program, but I'll just do it again. So I'll click the arrow, and the arrow stands for upload, and it's sending the program through the serial port to the Romi. Okay, and there it goes. So it's going for a second, then stopping for a second. If we want it to go a little bit faster, if you want to see what full speed is, we can change the 60s to 300. You see how fast this thing can really go. Notice that it's propped up on a box, so it doesn't drive off the table. That would be bad. Okay, here goes. It's going to download it in just a second. And then so that's full speed. I'll just turn it off. And that's it. So that's what you have to do to write a Romi program.